Okay, today we're going to talk about elements and compounds. The essential questions for today's lesson is what is the difference between elements, compounds, and mixtures? So what that means is by the end of these notes you should be able to tell me some of the similarities between the three, but mainly how all three of those are different. So let's start with Dmitry Mendeleev. He was from a country called Russia in northern Asia, and he was a chemist and an inventor. The reason why we're learning about Dmitry Mendeleev for this unit is because he was the first person to look at elements and realize that they had similar properties that could be arranged based on their shared characteristics. So he's kind of known as the father of the periodic table. The first thing he looked at was their atomic weight, and then he looked at some of the properties they shared and began to arrange them. Now, during his time, we didn't know about all of the elements we know about today, but based on the little bit of information he did have, he was able to look at what all the elements had in common in each group and predict properties of 8 elements that hadn't even been discovered yet. So how is matter classified? As you can recall, matter is anything in the universe that has mass or volume, and volume, excuse me. So mass and volume. Volume meaning it takes up space. Matter then can be divided into 2 categories. It is either a pure substance or a mixture. If it is a pure substance, it can further be divided as either an element or a compound. Now, mixture is one category in itself, but there are many different types of mixtures. For example, there's heterogeneous and homogeneous. We've got solutions and colloids. So even though they're not listed there, do keep in mind there are different types of mixtures. So again, as I said earlier, matter is everything around you. It has mass, it takes up space, and all matter is made up of these tiny little particles called atoms and molecules. Matter can exist in 4 states, technically, but the 3 main ones that we learn about are solid, liquid, or gas. That 4th state you might have heard of before, and that would be plasma. So a quick review on the states of matter. The first phase would be the solid phase of matter. An object that is in the solid phase of matter is going to have a definite volume and a definite shape. Its molecules are tightly packed together, but even though they are really, really close together and tightly packed in together, it doesn't mean that they're not moving. They still move, but just very barely. They can't flow past one another or slide past one another easily. They just kind of vibrate off one another. Think of it as if your phone is sitting on a table and it begins to vibrate. It's not totally still. It moves just a little bit as it bumps up and down against the table. That's kind of how the particles of a solid move. Next, we have the liquid phase of matter. The liquid phase has a definite volume just like a solid. However, it does not have a definite shape. A liquid is going to take the shape of the container it's in. Because it takes the shape of its container, that means it flows easily. And it flows easily because the particles are spread a little bit further apart and they can easily slide past one another. If a liquid flows very quickly, we say it has a low viscosity. And if it flows very slowly, like honey or molasses, then it has a high viscosity. Viscosity is a liquid's resistance to flow. Next, we have the gas phase of matter. In the gas phase, matter does not have a definite shape or a definite volume, so it's kind of the complete opposite of a solid. There's a lot of free space in between the particles, and they're moving very rapidly. They've gained a lot of thermal energy, which translates to a lot of kinetic energy. So they're moving all around and they're bouncing off one another. Similar to a liquid, a gas will also take the shape of its container. However, different from the liquid, it takes the volume of its container. So earlier I said matter can be categorized into 2 classifications, pure substance or mixture. So a pure substance is something that has a definite and a constant composition. It's not going to change. It's either going to be an element or a compound. And some examples would be salt or sugar. Salt and sugar are both examples of compounds. Elements would be any of the things that you see on the periodic table of elements, which we'll talk more about here in a second. If you look at the picture over on the right, I have 3 models of elements and compounds. The first one shows a model of the element hydrogen. As you can see, it's represented only by blue circles, and they are all separate from one another. Now, a compound could also be 2 atoms of hydrogen, which would form a molecule. As you can see here, they're all the same color still, but now they've bonded together. And since we have 2 or more of these atoms of hydrogen, we call it a compound. The second type of compound could be any molecule that contains two or more different types of atoms. So here we have the molecule for water, which you can tell kind of looks like Mickey Mouse. And water is two hydrogen atoms that have bonded with one oxygen atom. So what is a molecule? A molecule is going to be two or more atoms that have bonded together, and this represents the smallest particle in a chemical compound that can take place during a chemical reaction. A molecule will have the same chemical properties that of the element or the compound it is made of. Some molecules consist of two atoms of the same element, like the two atoms of hydrogen I just showed you, or in this case, two atoms of oxygen. Other molecules consist of two or more different types of atoms, like the water molecule. So what is an element? An element, as we just said, is a pure substance, which means it cannot be broken down into any other substance. It is represented on the periodic table by a symbol. So when you look at a periodic table and you see the one or two letter abbreviations, we call that its chemical symbol. Some of them make a lot of sense, like H is for hydrogen and O is for oxygen. However, some of them not so much. For example, AU is gold. Now you'll notice with the two-letter chemical symbols, there's always going to be one that's capitalized, typically the first one. If you only see one capital letter, that represents an element. When you see two or more capital letters, then you're going to be looking at something called a compound. So a compound is also a pure substance similar to an element, but it's a little bit different. A compound is formed when you have one or more elements that have chemically combined during a chemical reaction. Once they've chemically combined, they form an entirely new substance, and we represent that by a formula. So an element is represented by a symbol, a compound represented by a formula. For example, the chemical formula for salt is NaCl, otherwise known as sodium chloride, and we get salt whenever one sodium atom chemically bonds with one chlorine atom. Now I said that whenever these chemical reactions occur and we get these new compounds, they have all new properties. So if you look at salt, for example, totally harmless substance, something that we eat almost every single day. However, sodium is very explosive when it comes in contact with water, and chlorine is actually a very poisonous gas. Now when you eat salt, you're not poisoning yourself, and when you mix salt with water, it's not exploding. And that's because during that chemical reaction, when those two atoms bonded, those properties changed. Now when we look at different molecules, you'll notice sometimes there are numbers, and those numbers represent the number of atoms for each element that make up that molecule. So the way you count them is very simple. Remember, first I said one capital letter means an element. Two or more capital letters means it's a compound. So in this case, Na2O, we have two capital letters, the N and the O, so that tells me those are two different elements. Na represents sodium, and O represents oxygen. So I have two different elements. Now you notice after the sodium element, we have this subscript, the number 2. That tells you how many atoms there are in this particular molecule. So I could say that I have 2 atoms of sodium. And then if you look at the O, there isn't a subscript. If there's no subscript, that doesn't mean 0, it means 1. So I can conclude that in this compound, I have 2 sodium atoms and 1 oxygen atom. Now let's do some practice. Get with your table, or you can get with a partner or a parent or a sibling, and discuss how to count the number of different elements in a compound, and then complete this chart here on the right to give you some examples. We'll do the first one together. We have H2O, which is the chemical formula for water. The number of different elements, we have 2 hydrogen, or 2H, since the number 2 comes after the H. And then O is our next capital letter, and there is no number, so remember that means 1. So in the second column, I would put there's 2H and 1O. Now the name of the elements, H stands for hydrogen, and O stands for oxygen. Go ahead and pause this video and do the next 3 on your own. Okay, by now you should have completed the chart. The second one, NaCl, sodium chloride. Na stands for sodium. There's no number, so you should have just said that there was 1 atom of sodium. Cl stands for chlorine. Again, there's no number, so it should have been 1. Next, we have the chemical formula for glucose, C6H12O6. There are 6 C atoms. C stands for carbon. 12 H atoms. H stands for hydrogen. And 6 O atoms. O stands for oxygen. And finally, we have NaOH, 3 different capital letters, so 3 different elements again. Na, 1 sodium, O, 1 oxygen, H, 1 hydrogen. Now this brings us to our last slide, which is explaining what a mixture is. If you can recall all the way from the beginning of this presentation, matter can either be a pure substance or a mixture. So what a mixture is, it sounds very similar to a compound. It is a combination of many different elements like a compound. However, in a mixture, they're not chemically combined. They're just physically combined. Because they're physically combined, there was no chemical reaction that took place, and they can easily be separated. For example, here I have trail mix. I can see all the different parts of trail mix. It's not evenly dispersed, so we would call that a heterogeneous mixture. And I know it's a mixture because I physically combined all the different ingredients, and I can easily separate them all again. The other type of mixture that I mentioned earlier was homogeneous. A good example of a homogeneous mixture would be salt water or sweet tea. A homogeneous mixture is going to be a mixture where all the contents are evenly dispersed, so you can't easily see everything it's made out of. So if you think of salt water, unless you drink it, you probably aren't going to know it's salt water. It's just going to look like water, and that's because the salt in the water has evenly been distributed. So to make sure you fully understand this lesson, we'll bring you back to the essential question, which was, can you differentiate between elements, compounds, and mixtures? So remember, an element or compound is going to be a pure substance. It cannot be broken down into its original form unless it's a compound, but then it has to go through a chemical reaction, and it's quite difficult to do. Compounds are made of 2 or more different types of elements that have been chemically combined. And then mixtures are not pure substances. They've been physically combined. They can be made up of 2 or more elements, 2 or more compounds, or a combination of both, and they are very easily separated.